Good morning, students. Myself, Vijay Shankar from ECE Department, Civil Engineering College. In the last classes, we completed the examples related to the transmission lines 1 and transmission line 2. Today, we are going to discuss about the examples in the third unit, that is electrostatics. The first one, a charge Q1 is equal to minus 20 microcoulombs is located at the point P, with the quadrants minus 6, 4, 6, and charge Q2 is located at the 50 microcoulombs is located at the 5, 8, minus 2 in a free space. Find the force exerted on Q2 by the Q1. They're asking that to find the force exerted on Q2 by the Q1. Means, let us say here the Q1 is there. Due to the Q1, there is a force is exerted on Q2, means towards this direction. The Q1 is charge is 20 microcoulombs and Q2 charge is a 50 microcoulombs, and it is a Q1 is located at the minus 6, 4 and the 6, and Q2 is located at the 5, 8 and minus 2 in a free space. Epsilon r is equal to 1. Find the force is exerted on Q2 by the Q1 in a vector form. There. First of all, you can take the quadrants, the P and the R. The P we can see here, it's a Q1 means minus 6 AX bar plus 4 AY bar and 6 AZ bar. Okay, means the point P, there is a charge Q1, and at the point R, a charge Q2 is placed. And R is 5 AX bar and 8 AY bar and minus 2 AZ bar, considering here the Cartesian coordinate system. They're asking the force is exerted on a Q2, so F is equal to nothing but F2. The force is towards this direction. Due to the Q1, the charge Q2 is moves towards the direction here. F2 is equal to Q2, Q1, the product of two charges and inversely proportional to the square of the distance between them. What is the distance here? The R. That too from R1 to. Okay. And 1 by K is a proportionality constant. That is 1 by 4 pi and epsilon naught R12 square. The square of the distance between them. And it is towards the direction A12 bar, the unit vector. A12 bar. Okay. And now we can find the distance here, the R12. R12 bar is equal to. I'm always saying that is a sending end and the receiving end. Take the from the receiving end to the sending end, subtraction values of each quadrant. 5 minus of minus 6 is 11 AX bar plus, and 8 here, the y there, and 4, 8 minus 4 is a 4 AX bar, AY bar, sorry, plus, and minus 2, and here the 6 is there, minus 2 minus 6. Totally it is a minus 8 AZ bar. You get the 11 AX bar, 4 AY bar, and minus AZ bar. And it is a distance is square here. The magnitude, if you can take R12 bar is equal to under root of 11 square, 121, 4 square, 16, and minus 8 whole square, 64. So totally you can find out here they got a 14.1774 Okay, my dear students. So the magnitude you got, and see the Q1 and the QT is placed in this direction. The Q1 is a minus 6, 4, and 6, and QT is a 5, 8, minus 2. You can find out the unit vector also. So what is the unit vector formula? The unit vector A12 bar is equal to R12 by the magnitude of R12. It's a vector form. What is R12 here? The 11AX bar plus 4AY bar minus 8AZ bar whole divided by the magnitude we got, it is a 14.771774. So simplify this and you can write this as a 11 by 14.177 into AX bar plus 4 by 14. Find the value and you can write here the minus plus AX bar and minus 8 by 14.1774. You can write here the value and AZ bar. Nothing but the A12 bar is equal to. Understood? And using this, substitute the values. Substitute the values here. A12 we got the 0.77 and the 0.28 and minus 0.568. All you can divide with the 11 by this one and 14 by this one and 8 by this one. Okay. Then you'll get the A12 bar. Substitute the values of A12 bar in the F2. What is the F2? Q1 and Q2. The Q1 is given is a minus 20 microcoulombs. So minus 20 into the power of minus 6. And Q2 is a 15 into the power of minus 6. And 4 pi, it is in the free space. Epsilon r is equal to 1. Epsilon naught is equal to 8.854 into 10 to the power of minus 12. This is a standard value, my dear students. Into 10 to the power of minus 12. And we got the magnitude is a 40.1774 is R1 square A12. So A12 you can multiply this total function AX, AY and the AZ. So this total value you can find by using your calculator and multiply with this 0.7758. You get the minus 0.0346. And the total value you can multiply with the 0.2821 is minus 0.01261, and total value of this and multiply with the minus 5.5642, you'll get plus 0.02522 AZ bar. Okay, that is a F2 bar. They ask find the force exerted on Q2 due to the Q1. And its magnitude is, you can write the AX bar coefficient square and AY bar coefficient square and the AZ bar coefficient square under root. You'll get the 44.634 millinewtons because it's a force is measured in the newtons. Got it, my dear students? The next example here is a 4-point charges. 4-point charges, each of 10 microcoulombs are placed in the free space at the points 1, 1, 0, 0. Let us see here in the diagram they are showing there is a P. The first one is 1, 1, 0, that is A. Let it be the Q1. And minus 1, 0, 0. Minus 1, 0, 0 is at Q2. Let it be the B. The 0, 1, 0 is a C. Let the charge is a Q3. And 0, minus 1, 0. The point is a D. The charge is assuming the Q4. Milli, all it is a millimeters, that is a respectively. Determine the force on a point charge 30 microcoulombs. Here the charge is there. The charge is 30 microcoulomb located at the point 0, 0, 1. Determine the force on a point charge of 30 microcoulombs located at this one. So there is a 4 charges are located. All these charges are 10 microcoulombs placed at 100, -100, 010, and 0-10 respectively. Determine the force of the charge of 30 microcoulombs located at the point 001. Using the superposition principle, as there are 4 charges exerted on a fifth charge, the location of charges is shown in the figure here. Let us see. Then you can find the A bar, the position of vectors of the 4 points at which the charges Q1 to the Q4 are located is obtained as A bar. A bar is nothing but it having only the one term is there, that is AX, because we are considered as a Cartesian coordinate system. Is a X, Y, and the Z. Y and Z is a zeros here, and here the X, Y, and the Z. Y, X and 0 is a zeros, and here the X, Y, and the Z, and similarly here also the X, Y, and the Z, and these here also the X, Y, and the Z. Let us see that point A having only the AX bar, and at the Q2, you see it is here also the X term only, so minus AX bar, and C there is no X and the Z, only Y, the AY bar, that is a positive, and at the D point there is no X and the Z, only we have the Y, that is a minus AY bar. Okay, the position vectors for the 4-point charges Q1 to the Q4 is located as obtained as we'll get AX bar for A bar, and the B bar is a minus AX bar, C bar is a AY bar, and D bar is a minus AY bar. Okay, while the position vector of the point P where the charge is 30 microcoulomb is situated at it is also 001 matters. So 001 means not the 001, you'll get it as a Z. So while the position vector of the point P where the charge is 30 microcoulomb is situated as a P bar is equal to AZ bar. There is no term of X and the Y. Now consider a force on Q due to the Q bar. So first of all, if I am taking here the F1 bar is equal to Q is a point, charge is located at the point P, and Q1, the charge is located at the A, and the force is exerted on the Q due to the Q1, that is F1. So 4 pi epsilon naught R square, that is from 1 to Q, A1 to Q. F1 is equal to, what is the charge Q here? Charge Q is at the location of the point P, so 30 microcoulombs, 10 power minus 4 into the charge of Q1 is 10 microcoulombs, 10 to the power of minus 6, whole divided by 4 pi epsilon naught. Epsilon naught is 8.854 into 10 power of minus 12 multiplied with and here the R1 square is there. Before that R1 square, you can find out the A1Q bar is equal to, it's a vector form of R1Q by magnitude of R1. What is the vector form of R1Q? Here the A bar and the AZ. So point A here, assuming, and at the point P is there. At the P, we have only the terms of the 0, 0, 1. And at the A, the points is 1, 0, 0, 0. 1, 0, 0, 0. So now we can take the P to the A. P to the A. So 0 minus 1, 0, here it is a force is exerted on the Q1 here due to the P. So 1 minus 0, or the 0 minus 0, sorry, here the force is exerted on this one, not here. The sending end is a 1, 1, 0, and the receiving end is this one. So 1 minus 0, not the 1 minus 0, sorry, 0 minus 1, so minus AX bar, plus 0 minus 0, AY bar, there is no A, AY, and 1 minus 0, AZ bar. Okay, this is a R1Q bar, the distance is towards like this. Sending and receiving end values subtract to the sending end values. So minus AX bar plus AZ bar, its magnitude is magnitude of R1Q is equal to under root of 1 square, nothing but minus 1 square plus 1 square is a 2 under root of 2. So we'll get root 2 here, root 2 whole square, and multiply here AX bar minus plus AZ bar whole divided by root 2. So find the value right here by using your calculators and having only the term AZ bar minus AX bar, all the terms here. So these are 10 power minus 6, my dear students, 10 power minus 6, 10 power minus 6, and here the 10 power minus 12 is get cancelled, and square and the root is get cancelled, and find all this value and multiply with this function. So what is the value? We got 0.9533 is a force F1. Okay. Now the second one, F1 we got, and the second F2. F2 bar is equal. That is a F2 bar is equal to the same thing. You have to find out the value A2Q bar is equal to, what is it, 2? That is a B point, and the P point is 0, 0, 0, 1, and the B value is 1, 0, 0, not the 1, 0, minus 1, 0, 0, I think. Okay. So what is the A2 bar? The value is R1 or not R2Q, R2Q by the magnitude of R2Q is equal to, so 0 minus of minus 1 is a AX bar, and there is no any Y, AZ bar, 1 minus 0, and whole divided by the same thing, you get the 2. So AZ and AX by under root of 2. Similarly, you can find the R3Q, that is a P minus C. What is the C here? The C is a 0, 1, 0. 0, 1, 0 with a 0, 0, 1 means the 0 minus 0, only there is no any X term, and 0 minus 1 minus AY bar plus AZ bar, minus AY bar and plus AZ bar under root of 2 only, having the coefficients is 1 and 1 only. And similarly the 4, 0 minus 1, 0 and 0, 0, 1. So 0 minus 1 means there is no any X terms will get, only the Y, that is a positive, AY bar plus AZ bar. AY bar plus AZ bar under root. So the force exerted F2 is equal to Q2 by 4 pi epsilon naught R2 square A2 bar, and substitute all the values and find the magnitude of F2 as AZ bar plus AX bar, the same thing, 0.9533. Everything you'll get the same values because Q is the same, and Q3, Q4, Q2, and Q1 is also the same functions. So only the change is magnitude is same for all the forces 0.9533, but the directions of AZ bar and AX bar and AZ bar minus AY bar and AZ bar plus AY. So the total force exerted on Q1 due to all the four charges is a vector sum of individual forces exerted on Q by charges is Ft bar is equal to Ft means the total force F1 bar plus F2 bar plus F3 bar plus F4 bar is take the common of 0.9533. The first one we got what is the first one? F1 bar is AZ bar minus AX bar. AZ bar minus AX bar. And second F2 bar is AZ plus AX. And third is AZ minus AY. And fourth is AZ and AY. So we can substitute all the directions and simplify this minus AX bar and plus AX bar. Minus AY bar and plus AY bar. And we have only the AZ bar and the AZ bar. 3. So 0.9533 into 3 AZ bar. Then we get the 3.813 AZ bar. Got it, my students? Is a very important and next example. So determine the electric field intensity. Now they are asking it is a electric field intensity. The last two examples is to find the force exerted on Q due to the four charges placed at surrounding of the Q. And the total force we find out the Ft bar is equal to F1 bar plus F2 bar plus F3 bar and the F4 bar. Now in the third example, they're asking that determine the electric field intensity at P is located at minus 0.20 minus 2.3 meters due to a point charge of plus 5 newtons, not the newtons, sorry, here, nanocoulombs at the Q 0.2, 0.1 and the minus 2.5. Determine the electric field intensity at P. So you have to find out the electric field intensity at the P here. The P is located at minus 0.2, 0 and minus 2.3. Due to the point charges, due to the point charge here, the charge is at the 5 nanocoulombs, that is at 0.2, 0.1 and minus 2.5. Means you have to find out the electric field intensity here at the point P, A12 bar. So first of all, you can find the unit vector AR bar is equal to, this is a sending end and this is a receiving. So subtract from here the receiving to the send, minus 0.2 and minus 0.2. You get as a minus 0.4 AX bar. And here the 0 minus 0.1. So minus 1 AY bar, or the minus 1, sorry. You'll get the minus 0.4 AX bar. Here the 0 minus, so minus 0.1 AY bar and minus 2.3 and plus 2.5. So plus 2.5 minus 2.5 means it's a plus value is the highest value and 2.5 minus 2.3 is a 0.2 AZ bar. and divided with under root of 0.4 whole square, that is a minus 0.4 whole square, plus minus 0.1 whole square, plus 0.2 whole square. This is an AR bar. I need to find, see here the AR bar is equal to, we got the same, the minus 0.5x minus 0.5 ay and 0.2 AZ bar, and the under root of this value is a 0.45825. Okay, my dear students. And the E is equal to, you have to find out the electric field intensity. E is equal to the charge Q is a 5 nano, 5 into 10 to the power of minus 9 whole divided by the 4 pi into 8.854 into 10 to the power of minus 12. And R square, what is R square here? The 0.45 is under root of this value, and AR bar also. So under root of this total value is a root of 0.45825 whole square, and AR bar is a value is a point. Substitute this value and find the AX bar coefficient, AY bar coefficient, and AZ bar coefficient. Okay, we'll get E bar is equal to minus 186.77 AX bar coefficient, and AY bar coefficient is a minus 46.694, and AZ bar is a 93.389. Got it, my dear students? The next example is calculate the field intensity, nothing but E bar only, at a point on a sphere of radius 3 meters. If a positive charge of 2 microcoulombs is placed at the origin, means they're asking that calculate the field intensity E bar at a point on the sphere of radius 3 meters. If a positive charge of 2 microcoulombs is placed at the origin of the sphere. Okay. Here is a 2 microcoulombs is placed at the origin. The value is a 0, 0, 0, 0. Okay. We can find out the electric field intensity. The formula of electric field intensity is a Q by 4 pi epsilon naught R square into AR, the sphere. Q is given 2 micro, 2 into 10 to the power of minus 6, 4 pi into 8.854 into 10 to the power of minus 12. And R is the radius is given, the 3 square AR. Okay, the sphere of radius is R, 3 meters. The E bar acts as a radially outwards along the unit vector AR bar in the spherical coordinate system. The formula is Q by 4 pi epsilon naught R square into AR. So simplify this one, 1.9972 AR bar kilovolt per meter into kilo means 10 to the power of minus, not minus, sorry, 10 to the power of 3. Got it, my dear students? So next example, a charge 1 coulomb is at the 200, and what charge must be placed at minus 200, which will make a y component of total E bar 0 at the point 1, 2, 2. So they're asking what is the charge of at the point minus, not the minus 2 and 0, 0. Got it, my dear students? So what is the A bar? Now I can find out the position vectors of A and the B and the R is given at the point where its charges is placed. One is 1 coulomb is placed at 2000. That is a charge 1, and we need to find the charge at the point P, not the P, at the point B minus 200, and the E bar you have to find wherever it is, that is a point P, is a 1, 2, 2, 2. So A bar, what is the A bar here? 2 into AX bar, the 2 into AX bar because there is no AY and the AZ, and the P is also minus 2AX bar, and the P is having the three terms. One is AX bar plus 2AY bar plus 2AZ bar. So the first of all, if I find the EA bar is equal to EA, means if the charge is Q1 by the 4 pi epsilon naught R A P square AP bar, it's a unit vector. Okay, means this is a line, whatever we have here, this is a term. So 1 minus 2, we'll get the AP bar, the unit vector is equal to 1 minus 2 means a minus AX bar, 2 minus 0 means 2 into AY bar plus 2 minus 0, that is a 2 into AZ bar, whole divided by the under root of 1 plus 2 square is a 4 plus 2 square is a 4. Is a total is a 9, 3 1. So minus AX bar plus 2 AY bar plus 2 AZ bar and divide with the 3. Got it, my students? So this is a value here, minus AX plus 2A and 2AZ bar plus why it is under root of, again they're checking that is in terms of the A and AAP bar, and here the R square is there, that R square is a root 9 whole square. Is totally the R, the magnitude under root of 1 plus 4, 4 plus 4 plus 4. And for the second one, EB, how we can find that is EB? Means P to A, not the P to P. The receiving end is a 1, 2, 2, 2, and here the sending end is a minus 2, 0. So 1 minus of minus is a 3, 3 into AX bar plus 2 minus 0, the 2 into AY bar plus 2 into AZ bar, whole divided by 3 square 9 plus 4 plus 4, 13 and 17. Okay, the 17 square, and in the A1 bar here, see here the root of 17 square and under root of this one, you get the 3AX square plus 2AY bar plus 2AZ bar and this one. So simplify this value and you'll get the Y component of E bar must be the 0. Got it, my students? And Q2 is equal to, what is a Q2? We can take only the AY and equate to the 0. Then after the Q2 is equal to minus 2.596 coulombs. Means what is the charge here? At the Q2, the point P, minus 200, the charge value is minus 2.596. Is a required charge Q2 to place it minus 200, which will make a Y component of E bar 0 at point P. Means the Y component only we have to take the 0. So let us see here in the Y component, what is the coefficient? 2 by 27. And similarly in this AY bar coefficient is also 2 by 70.0927 and the Q2 here. They're asking that one, what is the charge located at the minus 200? Okay. What is the charge must be placed at minus 200, which will make Y component of total E bar 0 at a point of 1, 2. They are saying that it is, they are asking that the E bar is a 0, will make the Y component 0. What is the charge at the minus 200? Got it, my students? So in these 5 examples, the first 2 examples, we find the force exerted on the given charges if it is a given is a Q1, you can find out the charge, find out the force exerted at the Q2 due to the Q1. And the second example, you can find out the force, the total force exerted on the Q due to the 4 charges. And remaining the examples, you can find out the electric field intensity, how you can find the electric field intensity in the different cases. Okay, my dear students.